call cannot be taken at the moment. Please leave your message after the tone.
Yes, voicemail, a telecom service we all know and love. In this lesson, we'll introduce the principles of voicemail in a SIP network, specifically at how messages are recorded, how the service is triggered, and at how recorded messages are accessed and played back. By the time we're done, you should understand the general nature and characteristics of voicemail. The voicemail service typically comprises two parts: the hard-working but unintelligent media server and the decision-making, instruction-giving, back-to-back user agent type application, a relationship we discussed earlier. In fact, we've seen already how the application sets up a media session between the caller and the media server, and then how it sends an instruction to play a message and capture incoming audio. Remember how the media server records inbound audio as a file and stores it in a repository ready for later playback? Well, that's the essence of voicemail. Imagine Dave calls Nath, but the application, perhaps on finding Nath's unavailable, applies voicemail instead, setting up a media session between Dave and the media server and instructing the media server to play a "please leave a message" type prompt. The media server then records Dave's audio, stores the file, and returns the file URL to the application. Later, when Nath calls in to collect his voicemail, the application sets up a media session between Nath this time and the media server and gives an instruction to play back the recording. So that's the essence of recording and playing back messages. Next, let's look at how voicemail's triggered. Increasingly, voicemail is a separate feature server, slotted in alongside other features at the application layer, relying on a session manager server to apply feature or application routing. Now, when Dave calls Nath, ignoring Dave's originating sequence, acting in terminating mode, the session manager, on finding voicemail in Nath's terminating feature set, routes the invite to the voicemail service. At this point, the voicemail server, or more specifically the B2B UA application, does nothing more than set a timer and pass the invite back for routing downstream. Then, if the timer expires before Nathan picks up, the voicemail app cancels the downstream leg, and the rest is history. It invites the media server, sets up a media session with the caller, and instructs the media server to play the prompt and record Dave's audio. Rewinding back in time a moment, it might be that on receiving Dave's invite, Nath is busy and can't take the call, so hits the button to reject it. The 486 busy response travels back over the same path as the request, back to the session manager and back to the voicemail server. Rather than send the response upstream, well, maybe the app chooses to apply voicemail, instead hacking Nath's phone, inviting the media server, and so on and so on. Now, some voicemail servers might offer a web interface or something through which users can set their preferences. Perhaps when a call comes in and things are set to unavailable, a voicemail session's established directly. The voicemail app again instructing the media server to play a prompt and record the incoming audio. With IMS and IMS type networks, some of the initial logic might well move from the voicemail server to the serving CSCF. Imagine Nath's already on a call when Dave's invite arrives. Well, the serving CSCF, knowing that Nathan's busy, might well route the invite to the Voicemail Now service on the voicemail server, prompting it to establish the voicemail session immediately rather than wait till later when a timer expires. It might even be that the provider offers an interface to the user's IFCs, allowing him to set his own feature routing rules. Rules like, for example, if a call comes in from sipdave@calibre.com between 8 in the morning and 5 in the evening, then automatically send to immediate voicemail. Modern unified communications networks such as these give control to the user regarding how his calls are routed and what features are applied and when. Now that we know how voicemail is triggered and how messages are recorded, next let's talk about retrieving messages. Now, messages can be retrieved in a number of ways. Enterprise phones might have a special voicemail button, and regular phone users might dial a feature access code, FAC. Either way, the same thing happens under the surface. A SIP invite with the feature access code in its request URI is sent to the session manager, who, after recognizing the FAC, routes the invite to the play voicemail service on the voicemail server, prompting it to set up the media session and play in sequence all the user's recorded messages. Another option is a web-based service. Perhaps the voicemail app offers a message list and, when triggered by a simple mouse click, streams the recorded message over the internet direct to the browser. Interesting, retrieving a phone message without using the phone. In fact, it's with scenarios like these we really start to get a feel for what's meant by unified communications. The unification, the bringing together of real-time telephony-type communications with non-real-time internet-type applications. Taking the idea one step further, well, why not have a voicemail service where an MP3 of the message is automatically and immediately sent to the user as an email attachment? Then, at his leisure, the user hears the message simply by clicking the attachment, the downloaded audio file played locally by the device's media player. Another possibility is to send the audio file to a transcription service, where the audio speech is automatically converted to written text and then sent in an email. Sometimes it's just more convenient to read a voicemail message than it is to listen to it. Now, enterprise users like the idea of a message waiting indicator, perhaps a light or something on the phone that tells them there's a new message. In SIP, the message waiting indicator uses subscribe and notify with a special event package described in RFC 3842, a message summary and message waiting indication event package for the session initiation protocol. During user login, as well as registering its details, the phone also subscribes to the voicemail notification service, the subscription being routed to the voicemail server by the session manager. Then, after recording a new message, the voicemail server sends a notify request to the phone, prompting it to illuminate the message waiting lamp. It's worth taking a quick look at the notify request. The first part is all the regular SIP headers we know and love, plus a few new ones, followed by a new type of payload. Note the method type, notify. Right away, I can tell from the very first glance, the purpose of this request is to notify me of some event. What type? Well, we check the event header. In this case, finding message summary, the defined name for message waiting. Note to a special content type, which tells the user agent which parser to use when reading the payload. Looking at the payload, we see that yes, there are messages waiting, 2 of them in fact. Note how they each have descriptions, including who left the message, the subject of the message, and its priority. Okay, one last point briefly. Some voicemail services may offer in-message DTMF. Whilst recording, if we mess up, well, a quick key press and we can start over. Receiving perhaps the hash tone, the media server updates the application with an info request, prompting it to send back an instruction to disregard the current file and begin recording a new one. DTMF can also be collected whilst playing messages. Perhaps after not quite catching all of the message the first time, Alice presses 2 to hear it again. The media server passes the DTMF back to the app and receives back an instruction to replay the message. Okay, that's a brief summary of voicemail. Remember, these are principles of voicemail, and different voicemail products will implement different features in different ways. but the principles are the same. In summary then, the voicemail service comprises two parts, the media server and a back-to-back user agent type application. Typically, voicemail is configured as a user's terminating application, causing the session manager to route all inbound calls through the voicemail server. If unanswered in a given time or if rejected, the call is connected to the media server and prompted to leave a message, his audio then being recorded as an audio file. Users access their messages by dialing a feature access code, or perhaps through a web interface, or even as an email attachment or a message transcript. Different voicemail implementations offer different voicemail features and do things in different ways. Not all voicemail systems are the same. Some networks, particularly those with IFC-based user profiles, might offer intelligent voicemail routing, where the session manager routes to immediate voicemail under certain predefined conditions. Others might offer DTMF controls during recording and playback, giving the user more options. Some enterprise systems might offer message waiting indicators that use a subscribe and notify process, as described by RFC 3842.